Hello, I'm Dan Hannard, physics teacher at Woodkirk High Specialist Science School. My great lesson idea is all about the physics of Kung Fu, looking at conservation of energy using the context of martial arts. Martial arts, really, at its very basis, is just the application of physics. It's all about applying forces and energy. We're going to convert gravitational energy into kinetic energy to see whether or not you would have the physics power, if you like, to break one of these boards. The equipment that's required for this lesson is quite standard stuff you'd find in any physics lab. It starts off with some small pieces of wood, some kilogram masses and a meter ruler. We also have a ticker timer, ticker tape and power pack. The first part of the task is you have to work out how much energy is required to actually break a board. The second part is you have to work out how much energy your moving hand can transfer. The breaking of the board itself is very straightforward. You take the board, you clamp it in between two desks, then with eye protection and floor protection, a bit of carpet and watching out for your feet, you drop a 1 kilo mass onto the board from increasing heights until it breaks. The reason I use this experiment is I've got a black belt in Kung Fu myself, but you don't need to be a martial artist to go through the physics of the experiment. The children find it very stimulating, very engaging, especially if you demonstrate at the end and you actually do break the wood. This is the worksheet that the students are going to be used. It takes them through, step by step, the measurements and calculations they need to do. It's pretty much foolproof, but they'll occasionally will need a bit of guidance with it.
90 centimetres.
The first bit of the lesson, as you see, is very noisy, there's a lot going on. You need to be very acutely aware of student safety. You've got masses dropping, you've got things being dropped from a height. You need to make sure that everybody's safe, they're wearing goggles, they're keeping their feet out of the way, people are following instructions. If people follow your instructions, then the actual risk of anything happening is quite small. Come and collect an orange ticker timer and a black power supply and one red and one black cable. Come straight at the front. Section 2 of the experiment, you need to find out what the kinetic energy of the student's hand is. To do that, you need to know the mass of the hand, you also need to know the velocity at which it moves, and that's why we use the ticker timer. Because they're going to do a downward strike, then it's best to have the ticker timer set up so that you can have a downwards motion. The students aren't going to hit themselves on the desk. You put the ticker timer on, and the students pull the tape down as fast as they can. This will produce a series of dots on the tape, each dot every 50th of a second. The students can count up 5 dots, and that's the distance travelled in 0.1 of a second. And then it's a simple formula, speed equals distance over time, to calculate the maximum speed that they moved.
We like doing all practicals and things like that. It's good to get involved and do it.
1, 2, 3, 4, 5. So that's how far your hand travelled in 1/10 of a second. You went from there to there. So you can use that formula, just speed is distance over time, to work out what the velocity in metres per second your hand was doing at that time. Today's group is a top set year 9. I have done this successfully with year 12 students before, where we've also incorporated ideas about conservation of momentum and made it much more higher level. And I've tried it with a lower ability year 8 set. Obviously they need much more guidance, but if you make it step by step, they can access the learning. There's one more measurement that you need to be aware of. If you look at the formula for kinetic energy on the bottom of your sheet, you'll see it involves not just the speed or the velocity of your hand, but also the mass of your hand. So rather than chopping off your hands, what we're going to do is we're going to use an estimate to estimate the mass of your hand. And you'll see on the sheet I've said that your hand's mass is approximately 5% of your body's mass. So that's... Key learning objectives here are for the students to be able to use the idea of conservation of energy, to do calculations for gravitational potential energy and kinetic energy, and being able to compare the two. There are also some How Science Works elements here, thinking about validity, fair testing, accuracy, and also room for improvement. What their students then need to do is use the formula for kinetic energy, half mv squared, to calculate the kinetic energy of their hand and compare that to the kinetic energy needed to break the board. If their hand kinetic energy is greater than the energy needed to break the board, then in theory at least, they could do what martial artists do.
In theory, I could break the board.
Yeah, I could. In theory, I could anyway. 'Cause, the total energy in my hand is higher than the total energy needed for the weight to break it. So, yeah.
I think I might have a good shot at it, but I think I might hurt myself doing it.
Do we think that this was an accurate experiment? We did this as quite a simple experiment, but is board breaking really that simple? Does anybody have any ideas? Sophie?
Yeah, because every time we dropped the weight on the board got looser, so it wasn't a fair test.
So how would we make it a fair test?
Start with a new board every time we dropped it from a different height.
Thanks, Sophie. Now, ordinarily, you could finish with a flourish by actually breaking the board yourself, but the only ones we could get hold of today were MDF. They're pretty tough, so I'm not gonna let myself slip up by breaking my hand on one.